In this video, we are going to talk about metric system. It is important that scientists around the world use the same units when they communicate to each other. If they use all different types of units, then every time they try to communicate to each other, they have to convert one number to the other because different unit, you're going to end up with a different number. So every time you're trying to convert a number, it's very possible that you make mistakes. In order to eliminate all possible unnecessary effort or mistakes, around the 1960s, scientists had a conference and agreed to the same unit, which is known as SI unit. So SI unit stands for International System of Units. SI units for mass is a kilogram, and we are going to use lowercase kg for kilogram, and SI unit for length is meter, lowercase m represent that, and SI unit for time is second, lowercase s is for that, and SI unit for electric current is ampere, and we are going to use capital A for that. SI unit for temperature is Kelvin, and we are going to use capital K. SI unit for amount of substance is mole, and for abbreviation, we're going to use MOL. This is something that I want you to memorize before we move on. So be familiar with them. Not all the time the SAT2 subject test they ask about the SI units, but sometimes they can ask you to end up some kind of calculation with SI units. Then you have to convert everything to those units. Kilogram for mass, meter for length, second for time, ampere for electric current. Actually, ampere, we're not going to use this so often in chemistry, as we are going to use more in physics. Kelvin for temperature, and mole for amount of substance. So chemistry, we are dealing with very small particles. So a lot of time we have to deal with very small numbers. So if you use just a kilogram or meter or second and Kelvin and mole, then you probably end up with a very small number with a lot of decimal points. To eliminate that problem, we're going to use the prefixes along with SI units. So here are some prefixes that we should be familiar with. I'm going to start from the large number to the small number. We're going to start from giga. Giga stands for 10 to 9. Mega, capital M, and that's 10 to the 6th power. Kilo, lowercase k, and that's 10 to the 3rd. Hecto is 10 to the 2nd, but we don't really use it so often, so we'll just put it in the parentheses. Deca, it's good to know, but again, we're not going to use it so often, so I'm going to just put it in the parentheses. Lowercase d stands for deci, and that is 10 to negative 1 power. Centi, I'm going to just use lowercase c, and that's 10 to the 2nd. Milli, micro, nano, micro, and nano. That's 10 to negative 3, 10 to negative 6, and 10 to negative 9. We sometimes use pico. I don't have any more room here, so I'm going to just move here a little bit. So after nano, we can have a pico, lowercase p, and that's 10 to negative 12. I also want you to memorize those prefixes as well. If it's too much for now, let's at least know kilo, centi, milli, micro. Let's memorize at least those 4 for now. Eventually, you have to be familiar with the rest of them, okay? And you also need to know the SI unit, as I told you before. You need to know mass, length, second, Kelvin, and mole. So pause the video for a second, try to memorize them all before we move on to next section. And once you're done memorizing, you can follow. We are going to use those prefixes and convert to units. So everything has to be in your mind, at least the one that I marked for now, in order to solve those problems. So let's practice a little bit. If I have 10 millimeters, I can write it like 10 millimeters, right? Using abbreviation. Or since milli stands for 10 to negative 3rd, remember? I can rewrite 10 times 10 to negative 3rd meter. Even though I just wrote 10, that's equal to 10 to positive 1. So if you have 10 to positive 1 times 10 to negative 3. I don't know if you remember this from your algebra course. It's like 10, 1 minus 3, so it's 10 to negative 2. This is 10 to negative 2 meter. And what was the 10 to negative 2? That is equal to centi. So that's equal to 1 centimeter. Or I can just simply write 1 centimeter like that. So again, 10 millimeter is equal to 1 centimeter. Let's do another one. How about 100 centimeter? That is equal to 100 times 10 to negative 2 meter. I can rewrite as 10 to 2 times 10 to negative 2 meter, which is 10 to 0 meter. You know 10 to 0 is equal to 1. So this is 1 meter. So 100 centimeter is equal to 1 meter. Let's do one more. How about 1000 meter? That's equal to 10 to the third meter. And then 10 to the third was kilo, remember? So it's equal to 1 kilometer. So 1000 meter is equal to 1 kilometer. If you can convert from here to here right away, that's great. But I want you to understand this step, okay? I want you to think about 1000 is equal to 10 to the third and 10 to the third is equal to kilo. I want you to be able to do that right away. This kind of step, we call that dimensional analysis. So you should be able to be very comfortable doing dimensional analysis by using different units, not just prefixes. Okay, I'm going to give you a bunch of examples for dimensional analysis as well. And here's the one fact that I want you to remember. 1 milliliter is equal to 1 centimeter cube. So centimeter is a unit of length. If you cube it, then it could be used as a unit of a volume, because in order to calculate the volume, you learned it from your math class. ABC, A times B times C is the volume of this cube, right? This is the volume. So if you have a cube, then that's a volume unit for the volume. So 1 milliliter is equal to 1 centimeter cube. That's one fact that I want you to remember. And one more, at 4 degrees Celsius, 1000 centimeter cube of water, I'm talking about water, is equal to 1000 milliliter, as we just discussed, and 1000 is equal to 10 to the third, and milli stands for 10 to negative third, so it's equal to 1 liter. And at 4 degrees Celsius, if you have 1 milliliter of water, that is equal to 1 gram of water. So we can convert volume to mass as well. We are going to use this relationship when we calculate density of water, but they're not going to give you this information. So you have to know at 4 degrees Celsius, if you have 1 milliliter of water, that's 1 gram of water. That's how you convert volume to mass. This is a volume, this is a unit for volume, and this is a mass. That's how you convert water from volume to mass. Since 1 milliliter is 1 gram, if you have 1 liter, that's going to be 1000 grams. I told you that SI unit of temperature is Kelvin, but we use more of degrees Celsius or Fahrenheit. So we should be able to convert the temperature that we have, usually in Celsius in science, to the Kelvin, because Kelvin is something that we want to use to communicate with other scientists. So here is the formula. Kelvin is equal to degrees Celsius plus 273. If I solve for degrees Celsius, that's going to be Kelvin minus 273. Here's example number 1. If I have a 10 degrees Celsius, that's going to be how many Kelvin? Let's do that. So I can simply add this number, substitute this number here. So the Kelvin is equal to 10, which is 283 Kelvin. Example number 2, if I have a 200 Kelvin, then how many degrees Celsius it will be? You can substitute this number to this equation or this equation, though this equation doesn't really matter. So degrees Celsius will be 200 minus 273, which is equal to negative 73 degrees Celsius. So once you memorize one of the equations, then you can convert from here to here. You can solve any problem. I'm going to stop this video here, and next time we're going to talk about scientific notation and significant figures.